All right, y'all. So 3.6 deals with solving applied problems. And these are still going to be the systems of equations that we did in 3.5. This will just be word problems over doing that, okay? So to get us ready for the word problems, they have a few problems where they want you to translate the statements for them. All right, y'all, let me let a few in real quick. All righty. So for the first one, they want me to translate the statement. All right, y'all, so let's see the statement they're giving me. The sum of three numbers is 50. All right, so they just want me to translate that statement. So we don't know the three numbers, but we know they're being added, remember? When you see the word sum, it means addition. So they're telling me that I'm adding three numbers. And remember, is means equals. Like I said, sum means you're adding. So basically, they're saying we're adding three numbers to equal 50. So I would write that as, since we don't know the three numbers, we'll just call them X plus Y plus Z. And then that's going to equal 50. Okay, so they'll have different choices for you to pick. But here we go. The sum of these three numbers is 50. And the same thing on the next one. They want us to translate the statement again. So y'all, this one says the first number is 50 more than the sum of the other two numbers. Okay. So we don't know this first number. So I'm just going to call that X. And then remember, is means equals. And then it says 50 more. So remember, more means you're adding to it than the sum of the other two numbers. All right, y'all, let one in real quick. Okay, so we don't know the other two numbers. So I'm going to let that be Y plus Z. But remember, it said 50 more. So that's going to be plus 50. Now, here's the thing on this one. Although we've got the right statement here, they want it to look like this one. They want everything on one side equal to the number. Okay, so since I want everything on one side equal to the number, I would actually subtract a Y and Z from both sides. So I'm going to subtract Y from both sides, and I'm going to subtract Z from both sides. Okay, that way I got everything on one side equal to my number. And y'all, I'm just going to put them in order. So my x will go first, then my negative y, then my negative z, and all that will equal our 50. So on this one, once you got it translated, you got to get everything on one side equal to the number, okay? All right, y'all, so that was just a little warm up to get y'all ready for these word problems. So the trick is, when they give you a word problem, you got to figure out what each sentence says to get your equations. And then once we got our equations, we'll try to solve this, okay? All right, y'all, so I'm going to turn it over so I got more room on my page because these take a little bit of paper on these if we're doing them by hand. And I'll actually do them by hand. And then remember, we can also do these in the matrix on the calculator. All right, y'all, so for this number 3 that's actually on your homework, it says in triangle ABC, the measure of angle B is 30 degrees more than 3 times the measure of angle A. So there's my first sentence. I know that the measure of angle B is going to be 30 more than 3 times the measure of angle A. Then it tells me the measure of angle C is 60 degrees more than the measure of angle A. So then, y'all, they say, find the measure of each angle. All right, so what we got us a triangle here. We don't know what it looks like, but we know it is A, B, and a C. So let's get our equations first, and then we'll try to solve this for these 3 angles. So I do know the first equation, it says the measure of angle B. So that'll be B is equals, and then it says 30 more than 3 times the measure of angle A. So that will be 3 times A plus or 30. Y'all hang on just 1 second. I'm going to have to shut my door. All righty. Yeah, someone's out there mowing and my dog is acting a little crazy. All right, y'all, let's get the second one. The second sentence says the measure of angle C. So C is my equals 60 more than the measure of angle A. So that's going to be A plus 60. Now, in a second, we will get everything on one side equal to the numbers. But y'all, I really need one more equation, remember? When I got 3 variables, I need 3 equations. So the question would be, what do we know about the 3 angles of a triangle? What do y'all know about them three angles? Oh, what do you got there, Jackson? Jackson and that, perfect. Everybody's getting it. All three of them angles equal 180. So I would know that A plus B plus C equals 180. All right, so what we want to do is get these two equations to look like this. So y'all on the first equation, if I want to move this 3A to the other side, all I got to do basically is change the sign of that number. So if this 3A is positive on the right side, if I move it to the other side, it would give me a negative 3A plus my B. That would equal the 30. So notice the first equation didn't have a C in it. Now the third equation don't have a B, but I'm going to do the same thing. To move this A to the other side, I would make it negative. So this sentence would give me a negative A plus my C equals 60. Okay, so remember, moving something from one side to the other, all we're doing is changing those signs, okay? That would be like coming in and subtracting an A from both sides. All right, y'all. If I do this on the calculator, and I'll do it after I do the actual problem, but when you're missing a variable, you put a 0 into the calculator for where that variable was, okay? All righty. So here's the question of the day. I've got three variables. Now, if you notice, this one's missing a C and this one's missing a B. So what I'm going to do is eliminate one of these because the other equation that, like if I eliminate the B with these first two equations, then I can automatically use this third one as my second equation since it don't have the B already. Or the same thing with the C's. If I eliminate the C here, I could use the second equation as that second equation in the system of two variables. So let me show y'all. I always pick a variable that's missing one, okay? So what I'm going to do on this, I'm going to eliminate, let's say the B. Okay, so to eliminate the B, I'm going to make one of these B's negative. So I'm probably just going to multiply the second equation by -1. So what I'm going to do, multiply second equation by -1, and then I'm going to add to the first equation. Okay, so notice, I'm not changing the first equation. I'm going to bring that down. A plus B plus C equals 180. Now, if we come in and take this second row and multiply everybody by -1, that's just going to change all my signs. That's going to make this a positive 3A. That's going to make that a negative B. And then that -1 times 30 will make that a negative 30. All right, y'all, but notice what happens. My B's are going to cancel. So I got 1 and 3, which gives us 4A plus our C is going to equal 180 minus 30, which is 150. So here's what I got. I got 4A plus C equals 150. Now, since this third equation doesn't have a B in it, it automatically becomes the second equation. So I got a negative A plus my C equals 60. All right, so now we got two variables, two equations. I'm going to pick one of these variables to eliminate. So y'all, you got two choices. You can either multiply this whole row by 4 to get rid of the A's, or you can make one of these negative and get rid of the C. So I think what I'm going to do, I'm just going to get rid of one of the C's. So I'm going to eliminate a C. So to eliminate the C, I'm going to multiply my second equation by -1. And then I'm going to add to the first equation. All right, doing that, my first equation is coming down. It's a 4A plus C equals 150. I'm going to come in and multiply this row by -1. So that's going to make that a positive A. Minus our C. And then negative times 60 makes that a -60. So y'all look at that. The C's are canceled. So I got 4 and 1, give me 5A. That's going to equal 150 minus 60, which is 90. All right, y'all, so I'm at the last step. I can now solve this for the A. So 5A divided by 5 will equal 90 divided by 5. That's going to cancel, giving me 1A. And then y'all, let's see, 90 divided by 5, that's going to give me what, oh, that's a 1, and then 40, that'd be a 18. So we know now that angle A equals 18. So I'm going to substitute this back into one of these two equations. That'll give me my C. Once I got my C and my A, I'll go into one of my 3 original equations and solve for my third one. So now let's back substitute. So y'all, I'm just going to do, I'll do the first one. 4 times A. So that'll be 4 times 18 plus C equals 150. Okay, so I'm going from a C now. All right, y'all, so let's see. 4 times 18, that is what? 72 plus C equals 150. Now, solving that for C, I'm just going to subtract 72 from both sides. So that cancels. And let's see, 150 minus 72. That's what, 78 it looks like. So y'all look at that. I now know A is 18, C is 78. So all I need to find is B. So you could use this one if you wanted to solve for B, or you could plug in A and C and use the first equation. So I think I might just use this second one, okay? So -3, so I'm going to back substitute again. So I got -3 times A, which is 18, plus my B has to equal 30. All right, y'all, so -3 and 18 gives me -54, plus B equals 30. And then y'all, the final step, add 54 to both sides. And we get B is 84. So let's see. So Nat, you got it right. 78 for C and 84 for B. Okay. So that'll have like measure angle A equals, angle B equals, and then angle C equals. Now I said I would also show you this on the calculator. So y'all watch this. On the calculator, It's still a 3x4 because you got 3 rows by 4 columns. So it's still going to be a 3x4. But here's the numbers I would put in. For the first equation, I would do 1, 1, 1, 180. For the second equation, I had -3 for the A, 1 for the B. I had 0 C's, and that equaled 30. And then on the last equation, I had a -1 for the A, 0 for the B, and a 1 for the C, and that equals 60. So I'm going to just get you more practice on the calculator. So remember, I'm going to go to my matrix stuff. So on my calculator, I would hit second, x -1 to bring up my matrix. I'm going to go over there to edit and hit enter. So y'all, it's still a 3x4, so hit enter, enter. And then we put in our numbers. I had 1 enter, 1 enter, 1 enter, and 180. Second row, I had a -3, enter, 1 enter, 0 enter, and 30. Then that last row, I had a -1, a 0, a +1, and then 60 enter. So I got all my numbers in. So now I quit the screen by hitting second mode. I'm going to go into the math now. So I'm going to hit second, x -1 for the matrix. I'm going to highlight the math column and arrow down and get RREF, enter. And then for the third time, I'm going to hit second, x -1, and then I'm just going to hit enter. So y'all, it's now going to reduce that matrix. And if you look on the right side, we got our 18, 84, and 78. So y'all, either way, if you like doing it by hand, they're fun to do to get these right answers. Or if you'd rather do them on that calculator, plug them in there and see what it does, okay? All right, so the next word problem, let me get this moved back up. All right, also for this next example, they're telling us the sum of 3 numbers is 56. Then it says the difference of the largest and the smallest is 51. Okay. And then, and the sum of the 2 smaller numbers is 13. And then they say, find the numbers. So when I do this one, and you're dealing with like 3 numbers, and you got a large number, small number, I make my columns like this. I'm going to do my largest number first, then my middle number, then my smallest number. And then that'll equal whatever I get. So notice my first sentence, the sum of 3 numbers is 56. So y'all, there we go. That's just like the first problem when they gave us that translate the sentence. So the sum of three numbers is 56, will be x plus y plus z equals or 56. No, that is not bad to put in. What you got to watch out for is these next two. So look at this one. It says the difference of the largest and the smallest is 51. So the key word here is difference. Difference means subtraction. But remember, I got to get the right two letters here. So since I made this my large column, my middle column, and my small column, the difference of the largest and smallest, well, my largest is going to be the x. My smallest number is the z, so it's being subtracted, and it said that that had to equal 51. So that's why I sort of label my columns on some of these so that I know I get my signs right down here. And y'all, the third sentence, the sum of the two smaller numbers is 13. Well, my smallest numbers will be the middle and the small. Sum meant adding again. So that's going to be a y plus a z. And that said they equaled 13. So y'all notice once again, I've got three variables, so I needed three equations. Now, if you do this one on the calculator, you would put a 0 here and a 0 here, okay? Hey, also, this one's similar to while ago. If I eliminate the x's, this automatically becomes my second equation. If I eliminate the y, then the middle one becomes the second equation. So do y'all want us to eliminate the x's, or do y'all want me to eliminate the y? Or even I can eliminate the z's if you want to. So y'all pick a letter and we'll eliminate it. Oh, y'all, what am I getting? I'm getting x's and z's. Uh-oh, I got two z's. All right, y'all, so I guess I'm going to eliminate z. So, Kitty, you got sort of overrode on there with two of them, okay? But y'all, the z's ain't bad because I got a plus and a minus here, and then I can use this plus and minus there. So, I'm going to add the first two rows. I'm going to add the top two equations and eliminate the z. So I had an x plus y plus z equaled 56. I had an x minus z equaled 51. All right, y'all, let's see what that gives us. X and x will make 2x plus my y. The z's canceled. So those two added to give me 107. All righty. So then y'all said the z. So what I'm going to do is add the bottom two equations. So I'm going to add the bottom two equations and get rid of my z. So that one, I had an x minus z equaled 51. And then this one was a y plus z equaled 13. So y'all, let's see what we got. We bring down that x. We bring down that y. The z's canceled. And these will equal 64. All right, y'all. So my next two equations are 2x plus y equals 107. X plus y equals 64. So on this one, looks like we're going to eliminate the y. Or we could eliminate the x's. Either one of these will eliminate really quick. So I will do what you got, Jackson. I'm going to eliminate the y. So I'm going to multiply this whole row by -1. So I'm going to multiply second equation by -1. And then I'm going to add to the first equation. All right, so doing that, my first equation stays the same. 2x plus y equaled 107. I want to multiply this whole equation by -1, so I get a -x minus y equals -64. Oh, y'all did good on that because look here, the y's cancel. 2 and -1 leave me just 1x. And then 107 minus 64, that's what, a 43? So we know what x is now. So we're going to back substitute. All righty, so I can go into one of these two equations. So this is pretty easy. It says x plus y is 64. Well, no, x is 43. So 43 plus y equals 64. Oh, we got one move. Let's subtract 43. Those will cancel, and I get y equals, oh, that looks like 21. So I know x is 43, y is 21. I can plug them into any of these three equations and get the z. So I'm probably going to use the bottom one. Y plus z equals 13. Y is 21. So 21 plus z is going to equal 13. All right, y'all, we got to do here is subtract 21. And y'all look at that, I get z equals, what's that, a -8. Now this one has the answers like this. It'll say the numbers from largest to smallest. And then you just put in the three numbers from large to small. So let's say my largest was what, 43? My middle number would be the 21. And then my smallest number would be the -8. Okay, so that's the trick on those, is to get these equations and then start finding variables to eliminate, okay? All righty, y'all. So let me give y'all a second on that one. And then we got one more in this section 3.6, okay? All right, so this one's about food, okay? So here we go. By eating one egg, one cupcake, one slice of pizza, a child consumes 301 milligrams of cholesterol. So there's my first equation. Next it says, if the child eats 3 cupcakes, so 3 cupcakes and 4 slices of pizza, the child takes in 90 milligrams of cholesterol. Y'all, there's my second equation. And then third, it says, by eating 2 eggs, and 1 cupcake, the child consumes 566 milligrams of cholesterol. So what they want to know on this problem, how much cholesterol in each item. So y'all, I would set this one up pretty much like I set the one up a while ago with the large, medium, and small numbers. And I would make me an egg column. So my eggs will be in the first column. Cupcakes will be my second column. And then my pizza will be the third column. And then that's going to equal the milligrams, okay? So the eggs will be my X's, my Y's, and the pizza will be my Z, okay? So our first sentence, 1 egg, so that'll be X plus 1 cupcake plus Y plus 1 pizza will be Z. That all equaled 301. So y'all, what I want to know is, what equation could we make for the second line? This one says the child eats 3 cupcakes and 4 slices of pizza. They take in 90 milligrams. So are y'all going to use X's, Y's, and Z's, and then what are they going to equal? All right, Jackson, let me see what you got. 3Y, because that's my cupcakes, plus 4Z, because that's my pizza. That's going to equal 90. Perfect. So y'all, we got 3Y plus 4Z is going to equal 90. All right, how about my third equation? It says 2 eggs and 1 cupcake consumes 566 milligrams. So we need our third equation, y'all. So what am I getting? 2x plus y equals 566. Perfect. So y'all, 2 eggs plus my 1y equaled, what do we say? 566. So if you notice, this one's just like the ones that we've been doing. You're missing variables here. So we can try to get rid of the x's. We can try to get rid of the y's. or we can try to get rid of the z's. So y'all on this one, what looks easy to get rid of to y'all? So we will eliminate what y'all want. All right, so I'm getting some x's on this one. So y'all, I'm going to eliminate the x. So notice, all I got to worry about is these two because this equation don't have an x. So that'll be my second equation. I just got to find the first one. So it looks to me like I'm going to multiply the top equation by -2. So we'll multiply top equation by -2, and then I'm going to add to my bottom equation. All right, so if I multiply this by -2 up here, that's going to give me -2x minus 2y minus 2z. That's going to equal -602. Now my bottom equation was 2x plus a y equaled 566. All right, y'all, so let's see. The x's are going to cancel. -2 and 1 makes that a -y minus 2z. So y'all, let me see, what is that? -602 plus 566 is what, a -36. All right, so that's the first of my new equations. -y minus 2z equals -36. All right, we said the middle equation don't have x's, so we're going to bring that over. 3y plus 4z equals 90. All right, y'all, so either one of those won't be too bad to eliminate. So do y'all want to eliminate the y or the z? So how about Macy? What do you want next? My y's or my z? All right, so I'm getting y's on that. So we're going to eliminate the y. So y'all, this one's already 3y. This one's negative. So I just need to multiply the top row by 3 this time. So multiply the top by 3 and then add to our bottom equation. All right, y'all, so that's going to be all up here multiplied by 3. So we'll get -3y minus 6z equals a -108. This one stayed 3y plus 4z equals 90. All right, y'all, good job. The y's cancel. -6 and 4 give me a -2z. And then -108 and 90 give me a -18. So y'all look at that. We're down to one variable. We can now solve this for the z by dividing by -2. That cancels. Negative by negative makes that a +9. So z is 9, which means that means our pizza has 9 milligrams of cholesterol. Well, since I know z is 9, I can now come in, plug into one of these, and look for my y, okay? So I'll probably use this one. I know 3y plus 4 times my z, which is 9. That has to equal 90. All right, y'all, so solving that, 3y plus 36 equals 90. I'm going to subtract 36 now. So 3y, well, y'all, what is that? 54 look good? So 3y equals 54 divided by 3. And y'all, that looks like y is now 18. So there's 9 milligrams of cholesterol in my pizza. There's 18 milligrams of cholesterol in our cupcakes. So now we got to find the eggs. So I'm back substitute one more time. So since I'm looking for my eggs, I might just use this bottom equation. 2 times x plus my y, which was 18. All that has to equal 566. Well, it looks like these eggs have had the most cholesterol, don't it? So y'all, let's subtract 18. So let's see, 566 minus 18. I'm getting 548. And then let's see, looks like y'all divided by 2 on that. So that cancels and x equals, what's that, 2? Oh, Nat, you done got it. What you got? 274. Good job. So in the answer blanks, it'll say egg equals, cupcake equals, and then pizza equals. So remember, my eggs was my x's, which gave me 274. Cupcake was my y, which gave me 18. Pizza was my z, which gave me a 9. Okay, so if we added all 3 of them together, guess what? They're going to equal 301. All right, y'all. So that was basically 3.6. You got to do those 3-word problems, and then the first 2 were like translating stuff into equations. So what we'll do now, we will take our break, and then we're going to come back in and knock out 3.7. So y'all, I'm going to pause my recording for a second. All right, so did y'all have any questions on that? All right, y'all, so let's do, it's about 10:49, so let's do 10 minutes, and we'll pick up with the next section at 11 o'clock. All right, so let's do our break. Go to the point, Dad. Go to the point, Dad, right there. Go ahead. Go ahead. I'm going to try it. I know I'm showing 11 o'clock, so let's get into our last section for um test one is 3.7. And this section covers systems of linear inequalities. Okay, so remember, when you're looking at linear inequalities, inequalities are less than, greater than, less than or equals, and greater than or equals. So we're going to solve these by basically graphing them, okay? So here's the thing when we're graphing. Because what we're going to do, we're going to shade the regions of the graph that makes these inequalities true. So the first thing we got to know is what kind of line do we draw? And then we figure out where we're shading above the lines or do we shade below the lines, okay? So the first thing, if the inequality has greater than and equals or less than and equals, we use a solid line. Okay, the line will be solid when we draw those. If we have a greater than or less than, if they don't have equals under them, then we're going to use a dashed line. Okay. Now, the second thing you got to wonder on these, do we shade above or below? If it's greater than and equals or greater than. So basically, if it's got greater than in it, we shade above our line, okay? Now, if it's less than or equals or less than, we're going to shade below the line. All right, so graphing them on, so how do we get our graph? We're going to plot the line using at least two ordered pairs. Remember, it takes at least 2 points to get a line. So we're going to plot the point using at least two ordered pairs. In MATLAB, you'd use the line tool. Okay. Now remember, when you use the line tool, there's going to be a little thing under it. So you either have to choose the solid line or the dotted line based on your equation. Or how about based on the inequality? So if I got equals in it, I'm going to choose a solid line. If I don't, I'm going to use this dotted line. Then I got my 2 points plotted. I'm going to decide, do I shade above or below? based on that inequality. Okay, now here's the thing. Anything shaded makes the inequality true when we substitute back in. Okay? So anything that's shaded will make these things true. Anything not shaded would make them false. If it's got equals in it, anything on the line makes it true, okay? So y'all, what I'll do is I'm gonna pull up MathLab real quick, and that way I can show you how to actually graph in it on these, okay? So let me pull MathLab up real quick. Y'all, just a second here. Ooh, getting into Blackboard is a lot of links. So sounds like thunderstorms out here. Y'all getting a lot of thunder? All right, I'm almost there, y'all. So I'm there now. So let me go back to Zoom. So I'm going to share MathLab now so we can look at this first problem and show you how I would work it and actually graph it, okay? So y'all notice this one, it has y is greater than x minus 2. Well, there's a lot of values I can put into that x and y so that this is true, okay? Because it ain't equals, it says it can be greater than. So we got our problem. So let's go work it real quick, and then I'll show you how to put it in MathLab. Now, the first thing I do know, since it's greater than, and there's not no equals in it, in MathLab, I will use a dotted line. And since it's greater than, I'm going to shade above. So I know those two things. So over here, let's draw us a graph. And then we'll sort of label it after we figure out what kind of points we're getting. And remember, all I need is 2 points. So y'all, I can do 0. I always use 0 because it's easy. And then I can pick any other number I want to. So 1's a small number. So I'm going to use 0 and 1. So if I put a 0 in here, y is greater than 0 minus 2, which gives me y greater than negative 2. So when x is 0, y is negative 2. And then I'm going to put a 1 in. Y greater than 1 minus 2. Solving that, I get y is greater than a negative 1. So when x is 1, y is a negative 1. So those are pretty small numbers. So I'm going to number out 5. So I'm going to plot my 2 points. I got 0, -2. So 0 on the x's is in the center and go down 2 on the y. So that would be my 0, -2. Then my second point would be 1, -1. So I would go right 1 on the x's and down 1 on the y. So I got my 2 points plotted. I now need to draw a dotted line through these points. And then I need to shade above the line. So above the line will be up here. So that when we shade it, anything up here makes that true when we plug it in. Anything under the line makes it false. So we know what this is going to look like when we go to Math Lab. So y'all, let me show you, share my Math Lab to show you how to actually graph it. So I'm going to click to enlarge my graph. I'm going to choose my line tool. Now remember, right under here by the paint can, you got a solid line and a dotted line. I needed the dotted line. So I'm going to highlight it. So my first point was 0, -2. So there's 0, go down 2. Click that. My second point was 1, -1. Click that. So notice I've got my dotted line. Now I need to shade above it. So to shade above it, you got this paint can over here. You click the paint can, go above the graph, and click it. It makes it yellow. And y'all, that looks like what we had on our paper. So you would save that and then check your answer. Now, let me write this one down. What is that? 5x minus 2y is less than or equal to a -4. So let me solve this one, and then I'll actually show you how you can do these on the calculator. So I'm gonna go back to my paper. So y'all, whether you do this by hand or calculator, you got to solve this for the y. So to solve that for the y, you're going to have to move that 5x to the other side. So remember, if I want to move the 5x to the other side, you could just change the sign of it and make it a -5x over here. Because y'all watch, to move it, we subtract it from both sides. So those will cancel. I get -2y is less than or equal. So you don't have like terms over here. So I usually put my x's first. So I'm going to put -5x and then minus my 4. So look, it was positive over here. It's negative on the other side. All right, so now I need to make that a 1y instead of -2y. So we're going to come in and divide everybody by -2. But y'all remember this. If you're dealing with an inequality, what do you need to do when you divide by negative numbers? You need to reverse the direction of the inequality. So instead of less than and equals, it's now going to be greater than or equals. So reverse the inequality when dividing by negatives. Number. Now, I don't change them when I divide by positive numbers. If your y was positive and you divided by a positive number, it would stay the same. But when you divide by negatives, you got to reverse it. And y'all, let's see what we get. -2 divided by -2 makes that a positive y greater than or equal All right, well, these two negatives will make that positive. Can't do nothing with that, so we'll leave that at 5/2 x. And then at the end, these two negatives will make that a positive. 4 divided by 2 is a 2. All righty, so I'm going to figure out my points. Now, I do know this in MathLab. It's going to be a solid line, and it's greater than, so I'm going to shade above. Okay? All right, so let me see what kind of points I used to figure out my scale here. I'm still going to use 0. Now, my second number, I'm going to use a 2 because I got a fraction in front of the x with a 2 in the bottom. And that's how you can sort of get rid of plotting fractions, okay? So if we put a 0 in here, 5/2 times 0 is 0, okay? And 0 plus 2 will make that y value a 2. So basically, anytime you put a 0 in for the x, it's going to equal whatever that last number was. Now for the 2, I'm going to plug it in to show you actually what's happening. So that comes down. Reason I picked 2 because that 2 divides by 2, making that a 1. So basically, I got 5 times 1, which is 5, plus 2, which gives us a 7. So if you get rid of the denominator, you're just taking the top and adding, okay? So when x is 2, y was 7. So I need to go out just a little further on this one. So I'm going to go to 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, -5, -7, and then out to the left. -5, 6, 7. All right, y'all. So my first point, 0, 2. Starting at 0 on the x's, I would go up 2. My second point was 2, 7. So go right 2 and up 7. So we did have an equals under this. So we said it would be a solid line. So we got a solid line coming through here. And then we look at the final equation, which is greater than. Greater than, we said, shaded above. So above the line will be all this over here above that line. Okay, so we know what we now need to put in the MathLab. So we're going to go to that. All right, I'm going to click to enlarge my graph. So this was solid line, so I'm going to leave it on solid line, and I'm going to choose my line tool. Now, y'all, so first point was 0, 2. So starting at 0, I'm going to go up 2 and click. My second point was 2, 7. So I'm going to go right 2 and up 7. So I got my line, and it is solid. And remember, the shade above it, I'm going to grab the paint can and go above the line and click. At that point, we would hit save. All right, y'all, so I'm going to show you how you can do this on your calculators. So let me share my calculator here. All right, so I've got a y equals. So my equation was 5/2 x plus 2. Now, if I want to make it look like a fraction, I'm going to hit alpha, the green button, y equals, and enter. I'm going to put my 5 on top, come down, put in my 2. I'm going to arrow right, put in my X, and then I had plus 2. Now, this would draw the line, but here's the thing on the calculator. You cannot do the dotted line and solid line, but we can do the shading part of it, okay? You just got to remember on MathLab to choose the dotted or solid. But if I want to shade on this, I'm going to use the arrow left button, and I'm going to arrow left until I get on the left side of those equals. At this point, it's blinking. And I'm going to hit enter. And you see it's changing what's blinking over here. This triangle that's on top like that shades above. And if I hit enter again, this triangle that's on the bottom would shade below. So let's see, we had to shade above. So I'm going to click through and get to the triangle that shades above. So y'all, at that point, I could hit graphs. And y'all, there it goes. There's a line and it's shaded to the left side. Now, y'all, let me change my calculator because some of y'all got the new calculators that do the color. And I'm going to show you how you would graph on those. So I'm still going to go to y equals. I'm going to hit alpha y equals to get my fraction. I'm going to put in my 5/2. Arrow right, I'll put in my x and then my plus 2. So same way to start it. But notice on this one, I'm going to go all the way left and click it. It brings up another box. It gives me an option of arrowing left or right to pick a color. So if you wanted to shade in any of these colors, you would hit enter on what color you want. So let me see. I'm going to shade in red. I would arrow down on the line and right click through it. There's my triangle above. So that's going to shade above. And then I'm going to hit OK. So now when I hit graph, it's going to graph it, but it'll shade it red for us. So y'all, either calculator will do this. And I think the calculator 84 app I told y'all on the phones does it like I just did on this calculator, okay? All right, y'all. So we shaded it. We got it looking good. We check our answer. All right, y'all, look at this one. X is less than 3. So let me work that a little bit. Now, I love these ones. When you got X is less than or greater than a number, or X equals a number, when X is the only variable, these are going to be vertical lines. So this is a vertical line that crosses the x-axis at 3. Okay, so if you want to draw you a table of points, y'all, it don't matter what y values you pick, but since this is x less than 3 or x equals 3, if you're thinking about it that way, that means every x, no matter what, every x must be 3. So every x must be 3. Now, you can pick any two y values. I can use 0 and 1 for my y values. I could use 1 and 2, -5, -6. It don't matter. What matters is that every x must be 3, okay? Now, I do know this. There's no equals here. So in MathLab, we're going to use a dotted line. Now, x's, the x's get smaller shading to the left, or the x's get smaller shaded to the right? Well, remember, x's get smaller to the left. So since that's less than, we would shade left on this one. Okay. Now, unfortunately, our calculator is y equals, so you cannot do this one with the x's on the calculator. So let me go out. Looks like I can go out about 5. All right, so 3, 0. Go right 3 and stay at 0. 3, 1. Go right 3, up 1. No matter what y values you picked, you would go 3 and then go up or down to your y values. Okay? But notice, this is going to make a vertical line like we said. So we need to use a dotted line. So we would draw a dotted line straight up and down. And then less than on the x-axis would shade left. So we would come in and shade everything to the left side. So doing that on MathLab, let's see, I'm going to click to enlarge my graph. I'm going to choose my line tool and then come down here and make the selected object dashed. So now I'm doing a dashed line. So y'all watch this. I could go right 3, pick that. I could either go up 1, down 1. No matter what other point y'all picked, you could draw it on that vertical line. So we got our line drawn. So now we draw the paint can and click on the left side. So any of these x values that we have highlighted are going to be less than the x value of a 3. Like over here, 0. Any x value on that line would have an x of 0, x of 1s, x of 2s, and so on. All right, so you save that. You're going to check your answer. And then we go to our next question. So I think this one have y, right? So this one says y is greater than or equal to -1. All right, so let's go mess with that a second. So y'all, if the x's were vertical lines, the y, these are going to be horizontal lines. So if it's only got a y and no x, it's going to be a horizontal line that crosses the y-axis. At -1. Now, it's got equals under it, so this will be a solid line, and greater than is going to shade above. Okay? All righty, so let's make our table. And then we will graph that one right here. Now, since this one is a y, we can do this one on the calculator, and I'll show you that on it, okay? Now, y'all, here's the thing. Every y must be -1. Okay? Because that's what we're saying. Y equals -1 here. So every y has to be -1. So on this one, I can pick any 2 x values. So I like 0s and 1s, so I'm going to stick with them. So I now have 2 points. So let me go out about 5 again. All right, y'all, so let's see what we got. We had 0, -1, so 0 on the X, down 1 on the Y. I had 1, -1, so right on the X, down. So look, all my points are coming across this Y value of -1. Remember, anything on this line would have a Y value of -1. We said it was a solid line. So we would have our solid line going across. And then we said we would shade above, which means everything that I shaded has a Y value that is greater than or equal to that -1 Y value, okay? All right, y'all, so I said you could do this one on the calculator, so let me go find my calculator. I'm gonna click Y equals, I'm gonna clear this one out. So I had Y is equal to -1, so all I gotta put in is a -1. I'm gonna arrow all the way left, hit enter. So this time I won't say a green line or green shaded. I'm gonna arrow down. Well, y'all, mine's already on greater than, so I'm gonna arrow down to OK and hit enter. So now remember our graph shaded above. When we hit graph, it is shading above. Now y'all, let me show you something. On Y equals, if you want this to clear out and go back to normal, on the newer calculators, the CE, you highlight the equal sign and hit clear. Whoops, hang on. Okay, you didn't have to go to the left side. You just go to where your problem is. I had that -1 here. Just clear that out and then hit clear again, and it'll clear out that left side and make it back into a solid line. All righty, y'all. So notice at the moment, I really ain't solved a system of equations yet. We've just been solving inequalities. So we do have one problem in here, your last one, and it will actually be solving a system of inequalities. So here's the thing about that. When solving a system of inequalities, the solution, because it's got to make both of these equations true, okay? So when we solve a system of equations, the solution is the double shaded region. Where the two graphs overlap. Okay, so we'll shade one line. Then we'll come in and shade the other line. Where they both got the double shaded section will be our final answer, okay? So y'all, this is the last problem in 3.7 doing this. So they want us to graph the system of inequalities. So those first 3 or 4 problems were just getting us ready to graph in lines so that we could do this one problem. So my first equation is y greater than or equal to x plus 4. My second equation is y less than or equal to 1 minus x. So I'm going to graph both of these, and then I'm going to look for the double shaded region, okay? All right, y'all, so let me make my two tables up. Because remember, I got two lines. So I'm going to need two tables. I'll do the top equation on my first table and then my bottom equation on that table. But I will say on both of these, since I don't have fractions, I'm going to pick zeros and ones, okay? So here, if I put a 0 in for the x, 0 plus 4 gives me 4 for the y. If I put a 1 in for the x, I get 1 plus 4, which is 5. All right, so let's plot that line real quick. So we'll go out 5 so far. All right, so I had 0, 4, so 0 on the x, up 4. Then I had 1, 5, so right 1, up 5. There's equals under it, so they're going to be solid lines, both of them. So that was cruising through there like that. It's greater than, so this one shades above. So shading above, I would come in and just shade this whole thing above it, okay? So now we plot this second point. If I put a 0 in for the x, 1 minus 0 is 1. If I put a 1 in for the x, 1 minus 1 is 0. So I'm going to plot 0, 1. So 0, go up 1. Second point is 1, 0. So go right 1 and stay there since the y was 0. All right. I will draw that line through them points. But notice this one's less than. It's going to shade below the line. So below the line would be over here below it to the left of it. And I would just shade through there like that. So you're going to have 4 pictures on the answers. The one I need is the one where this left side is sort of shaded. And they're double shaded is in this section. So you're looking for the one graph that has that left side double shaded. Because what it does is it gives you each of these sections as an answer on their answers. So let me show you that. Let's go back to MathLab. Oh, we didn't do this one yet. So that was the one y less than or equal to -1. I'm just going to go to the next question, 5. Different numbers, but it gives you the same 4 pictures every time. So y'all, knowing what we just drew, would we pick A, B, C, or D? All right, so I lost my chat. Because remember, ours was shaded on that left side, so it looks like we're going to pick D on that one, okay? And then check your answer. So let me show you that one on the calculator. So let's go to our calculator. So y'all let me go to Y because I'm going to clear everything out. So my first equation was x plus 4. And remember, I'm going to go over here, hit enter. I'll keep it blue, but I'm going to arrow down. On the line, this one was greater than, so I'm going to arrow right. I got the greater than, arrow down and hit OK. Now I'm going to come down to Y2 and put in that equation, which was 1 minus x. I'm going to go all the way left and hit enter on this one. So I don't want it to be the same color, so I'm going to use red this time. And then this one was less than. So I'm going to click that's greater than. There's less than. So go down and hit OK. All right, y'all. So remember, I'm looking for the double shaded region when I hit graph. And y'all, there you go. It's the left side. You can tell has the blue crossing the red. The blue section above is a solution to one of the lines, but not the system. Just like the red below is a solution to one of the lines, but not both of them, okay? So y'all, that's the trick on 3-7 is to figure out what kind of line you're drawing, whether it be solid or dashed. Where are you shading, above or below? All right, y'all, any questions over that?